hello, hello, hello. Hello, hello.
My friend Matt Wall.
Hello, hello, hello. Hello, hello. Hello, hello. 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 Hello, hello. Hello. Hello, mic check. Hello, hello. Hello. Hello, mic check. Hello, hello. Hello. Hello and welcome to this live stream. Today I will be sharing with you my project, one of my projects where I built this ECG device. Let's start with what an ECG is. So ECG is a diagnosis of your heart, where they measure your electrical activities happening in your muscles, in your heart. So it can detect rhythm of your heart. So is it beating in a correct rhythm or not? It can detect lots of other issues with your heart, so that you can find out if there is any issues way before the thing gets too serious. So it's good to have that checked, or there are watches these days, smart watches that have ECG function. It's not that cheap, so it might be too expensive for some people, but there is an option. There are other devices which are not basically integrated to your watch, but there are some cheaper devices ranging from $100, €100 and up. There are various ways they can be used, like if you're doing exercises and you want to monitor that during your exercises, there are devices that you can use just by using your thumbs. So there are two sensors where you place your thumbs and then it does the readings. There are others where you have to stick the electrodes on your chest and stomach area, which are done basically in medical diagnosis. So doctors, they sometimes prescribe you this device where you have to put it on you and then measure or do the ECG. So yeah, it's a medical diagnosis, non-invasive. It's just sticking those electrodes on your body, and then it produces this graph where it shows the electrical activities happening in your heart. Okay, so I built one for myself, and it was around €10. 1/10 of like cheapest you can find in the market. So it is not professional or like doesn't have many fancy features, but it does basics. So it does cover basic stuff. So the monitor you see right now on the screen is it's just a website where I created this kind of visual where you will later see the ECG graph. And for the device itself, I used ESP32S3, which is a SoC system on chip. So it is a processor, memory, everything in one chip. So this is basically a computer. So the board is a custom designed board. It doesn't have to be custom designed. There are development boards you can buy for very cheap, around €4, €5, €10. Basically you could even buy just the module itself, the chip itself, and then you can just wire your stuffs to it. Doesn't require too much circuitry. Basically you will need a power source, charger circuit if you want for the power source, and then a module which is also very cheap. This costs you €5. I think I bought it for even cheaper, like €3.50 or something, but this costs you around €5, which is which comes with even the electrodes. Actually, I have already worn. It's on my chest, and this jack comes out of it. So there are 3 electrodes you put on your both sides of your chest, and then one on your lower abdomen, not lower abdomen, but like on the bottom of your rib cage on the right side. So with that 3 electrodes, you're ready to do reading. You connect the jack to this module, and then this module goes onto the ESP32 board here. So let me connect that. So there you go. It is now connected. All I need is now a power source. This is a battery, lithium ion, lithium polymer battery, 3.7 volts. Yeah, it doesn't need to be specifically this, but works. You can even use AA, AAA, whatever. Just combine them to make it about 5 volts, and then you're good. So right now you're already seeing I just turned it on, powered it up, and then you can already see the signals coming in there. So in the beginning it doesn't show you very accurate results. Too much error. 95 hertz. So it is reading. You can see the pattern there. This spikes, little spikes, are actually called R. So I can share another browser window where I can do the ECG. Then you will see something like this. Electrocardiography. So this is too much error. I think it's just basically I reused the electrodes, and probably that's the reason. And I reduced the resolution of the analog reading just recently. I haven't tested that yet. So that could also be the reason why there is so much noise. Anyway, let me share another window, and here Chrome. Okay, so I just opened up Wikipedia page with for electrocardiography, and here you will see the graph here. This is how it should look like. The main components of ECG is these P, R, and T waves. So you would see small bump, which is called P, and then there's a small dip, which is called Q, and there's another bump, spike basically, called R, and then again another dip, which is called S, and then small bump afterwards, which is called T. And these PR interval, RR interval, QT interval, they have their own significance. I have no deeper knowledge about that. You will have to talk to a cardiologist or a doctor, but this is basic ECG signal. This R here, that's what we are seeing there. These spikes, you see 2, 3, 4, 5. So also when I speak, it just gets worse. It's not working properly. Those spikes are R's. This the beats per minute, it sometimes shows for 50, 60, around that range, which seems correct, but because there's so much noise, it just fails to detect. Now it's better. So one of my electrodes is not placed properly. It's the adhesive, the glue is not really working. So now you see almost. So the reason why the beats per minute is not registering proper value, now it's doing that, but I probably have used a threshold that is way above what's the R spikes are at right now. So it's 180. I've used 75% of 240, 255, 255. So if it's showing at 180, around 180, 160, that should be about 60% only. A little more than 60% maybe. I can change that quickly. So basically I have the front end code open. I can change that to 255. Where did I put the 75% here? I can make it 60%. Now it will restart. Okay, now you will see the beats per minute properly. So it's showing 56 beats per minute, 59. So that's a proper heart rate. Yeah, signals are really bad. So if I touch on my electrode on my right, that's actually, yeah, now it's properly placed. Okay, this is how it should look like. Cool. So it's showing 52, 61, 52, 56, 49. That's my ECG. What I can do is I can zoom in a bit so that there is use more of the screen's space. Anyway, that's okay. Okay, so now it's working fine. When I talk or when I move my body a little bit, there is some issue with signals, but that's normal. You would basically lay on a couch or something while doing this, so my heart rate is going up. It's down again. 56, 57. Let me do a few squats. Now my heart rate will go up. So that was a little demo of my ECG device. I haven't tested it in a full, tested how long the battery lasts and stuff like that, because the battery is quite new. I actually recycled or reused it from an e-cigarette. So there are these days, it's quite popular that these e-cigarettes are quite popular. People use them, and then there are batteries inside them that are actually rechargeable lithium ion or lithium polymer batteries. Look like this. This is the battery which was inside a cigarette, inside an e-cigarette. So you break it open and then you get this battery out, and it works very well. You just need a charging circuitry, which looks like this. So this is a lithium polymer charger circuit. It has all the features you need. It has a USB mini, or you can also buy one with USB C. So you have to connect this to your battery and you can charge it. It shows you, there's a LED indicator that shows you that it's charging or it's done charging, and it has protections like over voltage or under voltage protection, all of that. So very cheap. It's you can buy, I think I bought 10 of these for €2, so very cheap. And you may find these for free if you smoke, and if you smoke these e-cigarettes, every time you're done with the cigarette, you just take it out and use it. This is a rechargeable battery. So and so that was free. This is almost free, which is how much? 20 cents. Then the circuit. So circuit that I have. So this was it. The battery and the charging circuit. The module, ECG module, it is called 808232. So 808232, I think it's from Texas Instruments. I might be wrong, but it probably is. Let me move the mic a little bit. Let me check. 8232. Yeah, it's Texas Instruments. So this is the module that does the ECG reading. It is this chip. Actually, the chip is produced by Texas Instruments, and the circuit itself, the module itself looks like this. On SparkFun, it costs you $21, which is fine, but you can find a cheaper Chinese versions in AliExpress or somewhere where it's way cheaper. Let's check. So this one here is 727.11.6. So this is 368. Yeah, you can basically find one for €6, less than €6 easily. So yeah, that's, say it, I think I bought it for $3.50 or something, so it was less than 5. So far this is €5, 20 cents, and this here, this was ESP32S3. I bought the module itself, and then I designed the development board. I wouldn't, yeah, basically at the end just one piece of this PCB is almost free, about 10 cents or something, and then the module itself is €3.50, something around that, and rest of the components are just really cheap, like 50 cents altogether. So that's €4, basically €4. €5, €9, and 20 cents. 20 cents. Battery was free inside the e-cigarette. So that's why it's under €10 or $10, all in one. And how do you program that? So basically there's a software called Arduino IDE. So Arduino IDE is the IDE where you can write Arduino code and then upload it to your ESP32 or Arduino or whatever chip you have. Basically ESP32S3 is so much easier because you can directly connect USB to the module. So it has a USB interface, so you can basically, this USB mini port I added here is basically just wired to the chip, two different pins, and that's it. So it has USB to JTAG, so it's just wire it and then connect to your PC. That's it. That's how you would program this. Very easy. And Arduino will detect that, and then you will Arduino IDE will detect, and you'll be able to upload code. And the code itself, you will need the ESP32 board library, which is just, you can find it in your Arduino IDE. ESP32 board Arduino IDE LIB, I don't know. So let's see here, prerequisites, preferences. Yeah, so this is the URL where you will find the board libraries. You add it to your preferences, and then you will find different boards under your board. No, actually you then install ESP32 library, and then you'll find that board in your board tools board, and there you will find all your ESP32 boards. Port, nothing important. And then we're using Wi-Fi feature of ESP32 because we are showing the data that ESP32 is sensing, or the module is sending the signals to ESP32, and then ESP32 is creating a web server and broadcasting the data via WebSockets. So we're running a web server with WebSocket within the microchip microcontroller here, and we are just broadcasting the data via the WebSocket. And the front end is basically JavaScript application. You just connect to the WebSocket and you have it. I can share the WebSocket code. Let me check code. Okay. So let me hide this. Okay, so I have this client.js where I have some configurations like these: analog resolution, number of data you want to show on the screen, and all other configuration, styles, index.html, and how this is connecting to the ESP32 is here. So it's creating a WebSocket connection to especg.local. This is the domain that that ESP32 will broadcast, and you can just simply connect to that, and you're connected to the WebSocket that that ESP32 has created. And after that, it's just reading the data every time and doing stuff like updating the visual. That's how the front-end code work. On the back end, it's not very different. I can check if I have it somewhere. No, this is the same project. Okay, here we have I mentioned using Arduino IDE, but I like to use VS Code with Platform IO, which does the same thing. You just code in a different environment. I'm used to VS Code, so I use this more often. So my Wi-Fi, my password, the libraries we're using here is ESP MDNS, which is where the DNS thing or the domain name is being created or broadcasted in the network. We're using async TCP and async ESP async web server, which is our web server that's hosting our WebSocket. That's here. So we're just sending. So during setup, I'm using a very low resolution, 8. It can't go lower than this, probably 4, but it will be useless. It can be 10, it can be 14. This depends on how accurate or how what resolution of data you need versus performance. Bigger these resolution, there's more work for microcontroller to do, so you need to find the balance. So I was using 10, which worked well, but sometimes there was like buffer overrun issues. Like when you have bigger numbers, the buffer just filled up, and then there were some issues there. So I used 8. There might be more performant way of handling this. I'm just basically just doing bare minimum here. So yeah, there can be more performant way of working with this. So try connecting to Wi-Fi, then once done, broadcast the MDNS. This is the domain name. It just adds the .local at the end. So I use ESP ECG. This can be anything like my ECG or whatever you like. So that will be your local domain name that you will use on your client-side code to connect to the ESP32's server. This is not needed. I just had it all this time, but not necessary. In any case, your router or your local network doesn't support MDNS. You will have to connect to the local IP address that the ESP32 will get. So that's why this is here. So you want to connect to the IP address instead of the domain, which is probably not working. And then we are just in the loop. We are buffering the data. So every 10 milliseconds, we will look at the analog pin 1. read the data, convert it to string, and then concatenate it within the buffer string. So every 81 seconds we send that text to the WebSocket. So we're just broadcasting that. So every 10 seconds, every 80 seconds, milliseconds. So there will be 8 data points every time the buffer is sent to WebSocket. So you have this batch of data being sent to the client, and that's it. So you have very simple code on the back end or the microcontroller, very simple code in the front end, and you have your ECG device. Yeah, for 10 euros and some 10 lines of code on the microcontroller, and some front-end work. Front-end work is basically I used a library called D3.js, which is data visualization library. This has lots and lots of examples. We could use very basic line graphs like this. So this could be easily used. And then just tweak stuffs here. You don't want to just go on and draw infinite number of points here. You just want to draw whatever is enough, or you just want to show as many points that fits on your screen and nothing else. So as I showed you before, I was showing 300 points on the screen. So yeah, so you have like at any given time you have only 300 points plotted on your graph. Yes, that's all the technology, that's all the hardware, software, whatever I have used for this project. Yeah, I hope this was kind of helpful, informative. There are none watching this stream, so whoever is watching in the future, thanks for watching, thanks for tuning in, and hope you enjoyed it, hope you liked it. If you did like the video, please consider liking the video wherever you are watching, LinkedIn or YouTube, and subscribe to my YouTube channel or follow me on LinkedIn. I have done some videos before on some of these projects. I have a blog where I post these projects. I haven't done one for this project specifically, so which I will be doing soon. So hope you will also read on my blog, and that's it. It's 12 and it's 1 hour of the stream. That was awesome. Just me alone talking to myself. Yeah, but in the future there are people going to be watching this, and thank you for watching, future person. Yep, that's it. Bye.